probability of independent and dependent events. So find the probability of 3 independent events. In a BMX meet, each heat consists of 8 competitors who are randomly selected into lanes from 1 to 8. What is the probability that a racer will draw lane 8 in the 3 heats in which the racer participates? Let the events A, B, and C be drawing the lane 8 in the first, second, and third heats respectively. The 3 events are independent. So when it says independent, what we're saying is that if it draws lane 8 the first time in event A, then it has no bearing on if it's going to draw lane 8 for event B. So one does not influence the other. So we're saying that we're going to do event A and event B and event C. So the probability of getting event A and drawing lane 8 is 1 out of 8 lanes. Then for event B, it's 1 out of 8, and for event C, it's 1 out of 8. We're multiplying these together because we're talking about event A and event B and event C. We end up getting 0.00195. Use a complement to find a probability. While you're riding to school, your portable CD player randomly plays 4 different songs from a CD with 16 songs on it. What is the probability that you will hear your favorite song on the CD at least once? So when it says at least once, that means that we could actually hear it more than once during the week, which is 5 days long. So we have to break down what the probability is of hearing the song versus not hearing the song. The complement is not hearing the song, so it's the opposite of the event. And in this case, our event is actually hearing our favorite song. So for one day, the probability of not hearing your favorite song is, we're looking here, we have 15 total, and we're choosing 4 of them because we said we're going to listen to 4 different songs, and they're random. The order doesn't matter. That's why we use combinations. Our denominator is the total of the 16 songs, and again, we're choosing 4 of them. So the reason why the numerator has 15 as a total rather than 16 is because one of those songs is our favorite, and we're trying to find the probability of not hearing our favorite song. So hearing or not hearing your favorite song on Monday or Tuesday and so on are independent events, meaning that what happens on Monday does not influence what happens on Tuesday and so forth. So the probability of hearing the song at least once is, the probability of hearing the song is the same as 1 minus the probability of not hearing the song. And then we have it raised to this 5. The reason that it's raised to the 5 is because we need to account for each day of the week. So the probability of hearing the song is 1 minus not hearing the song, so it's the complement, but then we're talking about each day of the week. Oops. So here's our answer. Find a conditional probability. So conditional probability means that the one event is happening given the condition that another event has already occurred. So a table shows the numbers of tropical cyclones that formed during the hurricane season from 1988 to 2004. Use the table to estimate the probability that a future tropical cyclone is a hurricane, and B, the probability that the future tropical cyclone in northern hemisphere is a hurricane. So here we have all this data. So the first one is the probability of a hurricane. So the number of hurricanes out of the total number of cyclones. So we're literally just reading them off of the table. Then we have the probability of a hurricane in the northern hemisphere. So instead of having the total of all the cyclones, it's specifically the total number of cyclones in the northern hemisphere. You're randomly selecting 2 cards from a standard deck of 52 cards. What is the probability that the first card is not a heart and the second is a heart if In the first case, you're replacing the first card before selecting the second, and in the second case, you're not replacing it. So for A, let A, uppercase A, or event A, be the first card is not a heart, and B, be the second card is a heart. If you replace the first card after selecting, then A and B are independent events. So the probability of A is 39 over 52. And then the probability of B is 13 out of 52. We're going to multiply those together, and we get 3 over 16. If we do not replace the first card after selecting it, that means that A and B are dependent events. So we say, what is the probability of the first event? Well, it's going to be the same as 39 over 52. But then the second event, what happens is that our B, what we're trying to find, is still 13, but we have one less card, so we have 51 left over.